Hello, apes, and welcome back to school. Uh, we're going to be doing flipped lessons this year. So what's going to happen is at home, you're going to watch 2 to 3 screencasts a night, maybe 4, depending on the length of the chapter. So that's about an hour worth of apes work that you're going to have to do before you come into the class. And then when we get into the classroom, we will be doing discussions. We'll be doing reviews on different procedures and processes that might need to be covered. We have a list of different activities that we're going to do. Our first activity is going to be Tragedy of the Commons, which we've already talked about in one of our screencasts over the summer. So that's something that you can look forward to. So we're going to start Chapter 2. And Chapter 2 is simply going to be a review of some of the biology concepts, life science concepts that we covered in biology, if you had me in biology, or Mrs. Mitchell in biology. Okay, so let's get started. In this lecture, we're going to cover some fundamentals of matter and chemistry. So we're going to do a little bit of a review of that. Going, oh, okay, you chose this class. You need to be excited about it. I'm excited to have you. We're going to look at energy and energy flow. Remember food chains and food webs. So we're going to talk about those. We're going to go over the process of photosynthesis, respiration, and we're going to include a little bit more on chemosynthesis. That was only mentioned in biology class, so we're going to focus on that a little bit. And then we are going to talk about plate tectonics and the rock cycle. We're going to do geological hazards and ways to mitigate the geological hazards. And I want to go back to the plate tectonics because you are going to do a project, and as I am going through these screencasts with you and part of this project you will do in class, you are going to make a book. And this is going to be one of those flip book activity books, where I'm sure you've seen them before and you've had them as little kids, where if you pull on things, it'll bring a picture, a hidden picture. If you push on things, it'll cause a little pop-up to come up. When you open up pages, a picture will spring out with you, or spring out to you, and you're going to make this book that's going to explain plate tectonics as one of your grades for this quarter. So that will be some of the activity time that you will be doing in class when you're doing your notes at home. Okay? All right, so your central case study takes us to Japan, the island of Honshu. And that's where there was an earthquake, the Tohoku earthquake that happened, and it caused a massive tsunami to occur. The waves of this tsunami went over any of the barriers, the seawalls that were there to protect the island. It caused flooding, and that flooding went to up to 9.6 kilometers inland, so that's quite a distance inland. It knocked the power out at the Fukushima Daiichi nuclear power plant. Big disaster there. They went days trying to stop extreme heating that was taking place in the reactors, and there were lots of leaking that happened of contaminated water. The fuel that was inside of these reactors actually melted, and it released that radioactive material. Sorry, my cat just came through. So please make sure that you are reading the central case study. It's on page 22. And again, it's important that you read articles like this because when you take your exam, a lot of the free response questions are based on what happened in the news 2 to 3 years, 4 years ago. So this is really current. As you can imagine, this was a major disaster and is still something that they're cleaning up today. And many countries now, because of this big earthquake and nuclear breakdown, they're considering questions and safety of nuclear power. And we're going to talk about nuclear power as being clean energy, and it really is, but it's the handling and containment that we need to take care of because of natural disasters like this. So look at this picture. Oh my gosh. So this is from the tsunami, water coming over the seawalls that normally would protect this town and this area. And you can see cars and automobiles being washed away, and that water is going to go into those buildings. Very, very tragic situation that happened. Not even to mention the fact that radiation was being leaked at the plant. So with that said, we need to understand the basics of chemistry, basic processes, so we know how to handle situations like the one that happened in Japan. So we're going to start out with the foundation of all science, and that is chemistry. Because that, as you recall, it studies the types of matter along with how that matter interacts. And interacts, hopefully you're thinking, oh, Mrs. Saunders, I got it. Reactions, chemical reactions, the breaking and the building of bonds, the changing of chemical properties that happen. And that's all that is good. Okay, so that's where we need to be thinking. So chemistry is going to be crucial for our understanding of a lot of processes, especially, as you well know, photosynthesis, cellular respiration, biogeochemical cycles. All of these are terms that you have had before that chemistry is the root of in our understanding. So this chemistry is going to help us understand how different gases are going to contribute to global climate change. And I don't know what your opinion is about global climate change. I don't know where you stand, if you're on the fence with it, or you have an extreme belief that no, climate change is not happening, or yes, it is, and I want to do everything I can about it. We're all at different points, I think, because of the inaccuracy of reporting it. But the science is real. And your textbook is going to tell you how real the science is, and global climate change is happening. So we're gonna look at that. We're going to consider how pollutants cause acid rain, and we're going to do an activity that you probably did with me in general biology. If you had general biology honors, you might not have done it with me, where we're going to simulate an acid rain activity and see just how damaging acid rain is. So we're going to look at those pollutants. We're going to consider the pesticide effects on health and wildlife and people. You already have a taste of this with Rachel Carson, and we're going to hopefully watch a movie on Rachel Carson, and that is called Silent Spring. They're doing away with our computers, so I have to figure out how we're going to play a DVD to see this movie. So that's going to be some of our downtime in class rather than taking notes. We're going to look at water pollution, and this is huge. And we're going to consider even plastics as part of that water pollution and how much water bottles we use. And I want to get you on the track where you don't use the water bottles, and start working on that right now. You don't use the water bottles. because of the ecological footprint that it leaves. And plastic takes thousands upon thousands of years to decompose, and some plastics never decompose. So it's important that, we start thinking about and putting our actions towards maintaining sustainably and not polluting. We're going to talk about wastewater treatment. If you're going to go to a wastewater treatment plant on a field trip, wahoo! It's going to be, I think, the most interesting and gross field trip you've ever had. And you're going to see how that brown, yucky, mucky water that comes in, the stuff we flush down our toilets, and how it turns out to be clear water that is potable, meaning not so much that you can drink it immediately, but they can put it out into the streams. And our fish are in the streams, and we're fishing from those streams. We're going to talk about atmospheric ozone depletion. That was happening huge in the 70s and the 80s because of different chemicals that we were using in air conditioning and in some aerosol containers. And we're going to see where that is. And then we're going to talk about some energy issues. And we're going to focus on renewable energy resources. We're going to talk about all of the negative of using fossil fuels and why we should get away from those fossil fuels. Pollution is one of them, but depletion of those resources, we're going to need to be able to go to some sort of renewable resource so that we have a constant supply of energy. So chemistry includes all of that. There's chemical issues behind all of that. So as we know, everything is made up of matter. So what's the matter? Okay. Everything has mass. Everything occupies space, even the things that we cannot see. And we have to be aware and go back and focus on that law of conservation of matter, that, and it says it really nicely here, that matter can be transformed from one type of substance into others, but it cannot be created or destroyed. So we're going to talk about our biosphere being a closed system, where everything in that system is recycled except the energy that we lose for heat. So you think about, I am eating lettuce today in my sandwich. I put lettuce on it, and that lettuce contains organisms that have died and have been decomposed and recycled into a usable food source. I know that just grossed you out on lettuce. Sorry about that. But it doesn't matter. It's the plant. Or I could have chicken, and that chicken contains recycled matter that has been decomposed. In the corn and grains, that chicken was fed. So everything is going to be recycled. It's not going to be created. It's not going to be destroyed. It's just changed in form. And that's how we're going to look at everything. We're going to keep that idea of the law of conservation of matter for everything that we talk about. Because the amount of matter stays constant, we're going to recycle those nutrients within the ecosystems. So that means we've got to keep ecosystems healthy in order to get the nutrients that we need. And we can't simply just, say, oh, I wish pollution didn't happen. I wish there was another way to get rid of waste. We've got to put those ways of managing waste away. I saw something where it was a TED Ed, and I think you watched it, where a girl had almost zero waste, that she produced zero waste, and she changed the way that she was living to produce less waste. And that's what we have to do. We have to think that way. Okay, we're almost at the end of the screencast. See you in the next screencast.